Okay, so we're going to look at a couple examples of quadratic applications. Before we jump into the problems, let's just kind of remind ourselves of the general shape and pieces of a quadratic. So remember, most of them that we're looking at here are going to be kind of in positive land over here in the graph. Okay, so we have this general shape of a quadratic. Remember, there are three main points that we really care about, and those three main points are the ones that we're probably 99% of the time going to actually be looking for on these application problems. So those 3 points that we care about would be the vertex. Okay, and we have to realize that a vertex has both an x and a y value to it. Okay, so there are a couple different questions that they can ask you here. So if any question that's going to be related to the vertex will have something to do with either a maximum or a minimum, or it might say the point at which there's the most or the least or something like that. Some maximum or minimum type word that tells you we're looking at the vertex, okay? And then there are two questions that they can ask you. So let's just say, for example, in just this little diagram, we're talking time and height. Okay, so if we're talking time and height, the x value, right, this is my x-axis here, this is my x-axis, this would be the time. So it could ask two things. It could say, at what time, let's just say this was a ball, at what time was the ball the highest? That would be the x value of the vertex, right, because that's the x value of the vertex, the time at which it's at its highest point. Or it could ask you just flat out, how high did the ball travel? And that would be the y value of the vertex, okay? So two things it could ask you, and it's always based on either of the labels. So whatever your function is talking about, and we'll look at drawing pictures, then you're looking at either the x value or the y value. So in this case, it would be the time at which it's at its highest point, or how high did it go? That would be the y, okay? The other 2 points that we are really concerned about are the zeros, and those are pretty easy to generally identify when they're asking you for them, because it says something about when it's on the ground, if it's talking height, if it's talking money or finances, it might be something like when there's no money or you run out of money or something like that, but that's generally when we are going to find the zeros. So vertex, just really quick as a reminder, okay. Vertex, remember we're working with the standard form of a quadratic, so that's y equals ax squared plus bx plus c, okay? And when we are trying to find vertex, the x value of the vertex is always going to be negative b over 2a. So we're using this a value and this b value, so the number in front of x squared is a, number in front of x is b. And then once we find the x value of the vertex, then we are just going to plug in for y. Okay, so that's vertex. Okay, and then for the zeros, you have options. Okay, the option that I'm going to show on this video is quadratic formula. Okay, but you also have factoring, or the last option would be graphing if you are able to have access to the graphing calculator on that particular problem. You can find the zeros that way. Like I said, the one that I'm going to key in on here is quadratic formula on this particular video. Okay, so we know how to find our zeros, and we have a general idea of what we're looking for. We know how to find our vertex, and we have a general idea of what we're looking for. So let's actually jump into the problems now. So scenario 1 says the number of bacteria in refrigerated food is given, shown by the function, and then that function 20d squared minus 20d plus 120, where d stands for the degree in Celsius, and f of d, which is our output, is the number of bacteria. Okay, so let's just draw ourselves a quick picture. It tells us that d, which is kind of like my x value, is the degree. So this is degree Celsius. Okay, and then it tells me my output, my y value, is the number of bacteria. Okay, so let's read our first problem. It says, at what temperature would the bacteria be the lowest? So it looks like my extreme value is going to be a lowest. So this is going to be a parabola that opens up. Okay, so we're coming down here to this vertex point. Remember when I said at the beginning of the video, you're looking for some kind of extreme word. So either it's a highest or a lowest, and we clue in on this lowest right here. Also in this problem, it says at what temperature. Okay, so I see temperature and lowest. So when I see lowest, I know I'm talking about vertex. When I see temperature, that is my x-axis. Okay, so this problem right here is asking me for x value of the vertex. Okay, so the x value of the vertex is x equals negative b over 2a. So let's go ahead and identify what I need. So b from the problem up above is the number next to the regular variable. It's negative 20. So x equals a negative 20. So anytime we have that minus a negative, it's going to change to a positive 20. Okay, over 2 times a. And a is the number in front of d squared, which is a positive 20. So it looks like we have 20 over 2 times 20, which is 40. And if I reduce that down, that's 1/2, or you could write it as 0.5. Okay, so it looks like at what temperature? So it would be 0.5 degrees Celsius. Okay, so it looks like at 0.5 degree Celsius, that's when the bacteria is going to be at its absolute lowest. Okay, all right, so let's move to B. So it says, how many bacteria would there be at the lowest point? So again, it's saying lowest, so I know I'm going vertex. This time it says how many bacteria. And if I look back over to my picture, the number of bacteria is up here on the y-axis. So I know I'm finding the y value of my vertex. So remember, I already have my x value. That's the 0.5. All I have to do to find y is just plug this in. Okay, so everywhere I see this d, I'm going to put in my degree. Okay, so we have 20. Instead of d squared, I have 0.5 squared. Okay, minus 20. And instead of d, I put in my 0.5 plus 120. Okay, so just a little bit of calculation. Always remember that exponents come before multiplication. So 0.5 squared is going to give me the 0.25. And then I multiply by that 20 out front, and that term is simply 5. Okay, minus half of 20 is going to be 10 plus 120. So 5 minus 10 is negative 5 plus 120 is going to be 115. So there's 115 bacteria. Okay, so kind of putting this entire scenario together, it looks like my vertex is going to be at 0.5 degree Celsius, which is the lowest point. There's going to be 115 bacteria. So that is a question where it's asking you about the vertex. Okay, let's look at scenario 2. So scenario 2 says the height of a baseball after Johnny hits a pop-up is given with that function, negative 16t squared plus 64t plus 190, where t stands for time and f of t, which is our output, is the height. Okay, so let's draw our quick picture. So we all know how a ball travels, right? It's going to go up in the air and come back down. Let's see. So t stands for time. So this down here is time, right? And then f of t stands for height. Okay, so my x value is time, my y value is height. All right, now it says on A, it says how long would it take for the ball to reach the ground? So hopefully you realize that that is a much different question than what the first scenario was asking us. The first scenario was asking us at the lowest point, or in this case it might say something about the highest point of the baseball. Okay, but that's not what it's asking here. It's asking about the ground. So remember, anytime we see ground or no money or something along those lines, we're generally talking about zeros. Okay, so I'm trying to find this zero out here about how much time, right, that's my x, has passed when it hits the ground. Okay, so finding a zero is like plugging a zero in for y. So I have 0 equals negative 16t squared plus 64t plus 190. And now, this is when I told you up at the beginning of the video you have options. Okay, so our options are either quadratic formula or factoring, or if you have access to a graphing calculator, you could plug this function in and find the zero that way. But I'm going to clue in on quadratic formula. So let me pull over to the side here. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is a formula that you have on your formula sheet on the test, okay? So let's go ahead and plug our numbers in. So a is a number in front of t squared, b is a number in front of t, and c is a number back here all by itself. So I have x equals negative b. So since b is 64, negative b is negative 64, plus or minus the square root, b squared. So let's go ahead and do that. 64 squared. Oops, sorry, messed up on my calculator. 64 squared is 4,096 minus 4 times a is negative 16 times c is 190. Okay, and that's all over 2 times a, so that would be negative 32 when I do 2 times negative 16. So now I want to figure out what that number underneath my radical is. So remember, multiplication always before you add or subtract, so negative 4 times negative 16 times 190 is 12,160, and then since that 4,000 number is positive, I'm going to add that on, so 4,096, that's 16,256. So this number here is all 16,256. Let's go ahead and take the square root of that. So square root of that number is going to be 127.5 if I round. Okay, so now I have x equals negative 64 plus or minus. We figured out that square root is 127.5 when we approximate there over negative 32. Okay, so now that I've simplified my radical, now I can go ahead and break into my two different problems. One with the plus, one with the minus. Remember, that's what this plus or minus means in there. So I have negative 16 plus the 127.5 over negative 32. And I have the minus. So negative 16 minus 127.5 over negative 32. Okay, so let's work that out. Remember to add across the top before you divide. So we have negative 16 plus 127.5, and then equals, and then divide that by negative 32. What's going on with my calculator here? Divide by negative 32, and we end up with negative 3.5. Okay. Now our second problem, we have negative 16 minus 127.5, enter, and that's going to be divided by negative 32, and that's positive 4.5 when I round there. So we have to think about, since we have two answers here, we have to think about which one makes sense in context of our problem. So if we come back up to our problem, we are looking at how long would it take for a ball to reach the ground. Hopefully there is no such thing as negative time, so we know that the negative 3.5 is out of there. So the only logical explanation, the only logical answer here would be 4.5 seconds.